Hello, welcome back to the second submission. In this submission, we have updates from the previous versions, from the previous submission, and we have tried to compare supervised and unsupervised machine learning, and also tried to increase the accuracy and precision of the results based on different algorithms that we tried over the last few days. Some of them include random forest, which was done previously. Using that, we identified features which were important, and then we went on doing clustering, and we also used random forest to actually predict. So let's go ahead and look at the progress, and we will show you. We'll walk through the code and see each portion of what we've done on RNA, clinical, and proteomics data. All these are performed individually, and we are not yet in a stage where we can correlate between them to identify the actual mislabeled sample and the correct label which should have been in that place. All right, let's start with clinical data. Our goal is to first understand clinical data and then go with proteomics, and then finally end with RNA for this update. For observing clinical data, we have three columns. The first column is sample. We have 80 samples, with each having their respective relation to proteomics and RNA tables. And the second column is gender, to identify whether the sample is a male or a female. And then MSI levels, there are two, MSI low and MSI high, which tells that whether if a person is about to die out of cancer or not. And now for starting, let's import libraries, NumPy, Pandas, and Matplotlib. And then the first step is to actually get the target data loaded into the variable, and then so we do pandas read CSV. Then we take the training data and load it into another variable, data. And since the gender and MSI are strings, we cannot perform clustering or PCA or most of the machine learning operations, and we need them to be converted to numerical data, integer values. Since gender is only of two types, male and female, so we take 0 and 1, and MSI also, since it's only two kinds of values that we have, we make it 0 or 1. So Pandas has a method to factorize. We use this, and once we print it, we see everything is changed from strings to integers. We're dropping the sample. We don't need this because we know that each of the row is corresponding to their respective columns in other tables as well. And to just check the kind of unique values that we have in the reduced data set, we still have 80. That means we have 80 different training data samples. And on this, we are performing k-means clustering with 4 clusters. The number 4 is decided based on 2 genders and 2 MSI levels. So male, female, low and high MSI levels. So 4 dimensions, so 4 clusters. And then once we do k-means, we get all the data sets clustered into each unique cluster that we set, and we can see that here. Let's move on to proteomics data now.
Hello, let us take a look at the data proteomics, and we're going to apply 2 algorithms on this. One is supervised and one is unsupervised. Well, let us take a look at the supervised one, and let's dive in. This is importing the libraries, then I'm taking the target and loading it into my data frame, taking the trained proteomics data and loading it into another data frame, checking if the training data is accurate if I'm able to extract it by data.head. Then I'm going to take the transpose and check the data. After that, I am going to replace the NA values, which I do not know, by the mean of each row for every individual row. And as you can see here, I've replaced this NaN with these values. Now, to check the label or the target of the proteomics data, now, my main aim here is to use the random forest classifier, which is a supervised learning. So random forest classifier is used where there is a lot of amount of data. And here I do have a lot data with me, which is why I'm using random forest. Random forest basically is a meta estimator which fits a number of decision tree classifiers on a various subsamples of dataset and uses averaging to improve the predictive accuracy and control over fitting. So I'm importing the random forest classifier from sklearn, modeling it, giving a depth of 10, after which I'm able to extract about 10 top features which were important in giving me the importance of the data on the Y label. So this is basically extracting the importance and after which displaying the proteomics, which are top 10 based on this importance. So I get this is the output. Now to display how many points in the label are unique. So I got to know that only 79 are unique. After which the random forest classifier is used again. On the Y predicted train, which is this. So exactly now, what is this? This basically gives me the Y predicted train or the proteomics train data on which I used random forest classification. It gave me an output, and this output is the Y label. Now, when I did the comparison, I got a accuracy of 0.9. Now I'll perform the k-means clustering, which is a unsupervised clustering on the training proteomics data, having reduced features. So I got to know that only 79 are unique, as above. Then k-means happens on 80 clusters, and the fitting happens on the x-reduced. X-reduced was the 8 features which I extracted from these 10. And this is the Y label.
While dealing with the RNA data, we are going to follow the similar approach as we did for proteomics data. We will get the feature importance using random forest classifier, and after that we will predict the labels using two different approaches. First would be random forest and second would be clustering, where we will be using the features which are most important, which we will obtain from random forest classifier. First step would be importing all the important libraries and then importing the sum tab 2, in which the target which is the label, is there. We will particularly take the RNA sequence, as that is what we require right now. Loading the RNA data in the data frame. After that, we will transpose and check if the data is correct. We will be replacing the NA values with mean, and check the target for RNA sequence. Now from sklearn library we will use random forest classifier, so importing that, after which we will use random forest for feature importance. After fitting the model, we will see which features are most important. As it shows, these are the top 10 features which contribute most for the predicted label. Now taking 9 of these features and storing them in XReduced. As we can see over here, all those 9 features are extracted and stored in XReduced. This is to see that in Y there are 79 different outputs. Now we'll use the first approach where we are going to use random forest classifier to predict the Y labels. So the model will be random forest classifier. After that, which I will train the data, where the input X will be XReduced, which has reduced number of columns, and then we will predict the output, which would be the Y, which is target. On comparing Y with the original label which we are given in sum tab 2, we will get the accuracy. As we can see, we are getting 0.9 as the RNA accuracy, which means 90% of the data which was predicted is correct. Now we will take the unsupervised approach, where we do not use the label, and for that we are going to use k-means. From sklearn cluster, I'll import k-means, after which I will be creating 80 clusters, because there are 80 different values in the output, which is the label. As we can see, these are the different labels which are generated by using k-means. Now the numbers which are assigned over here are assigned internally, so what we will have to do is map them back to the original label in order to compare them with the label provided in the sum tab 2 for calculating the accuracy. So that would be our next step. Also, we are going to find a relation between all the 3 data types and compute an algorithm which gives us the relationship between them, and use random forest for feature reduction in further cases.
Once again, thank you for viewing the video. In the next one, we would come up with more updates and try to correlate files, different sections of files, so that we have better understanding of proteomics data, RNA data, and the clinical set. Please do provide any comments, and like, share, and subscribe. Thank you.